Picture this. You're walking through your living room, the afternoon sun is hitting the window just right, and you swipe your finger across a bookshelf. You look down, and there it is, a fresh, perfectly even layer of that annoying gray fuzz. We have all been there. Dealing with dust is this universally recognized, endlessly frustrating human experience. But what if I told you that the gray fuzz you just wiped onto your jeans is so much more than a boring chore? What if I told you it holds the secrets to the global climate, the origins of weather, and maybe even the epic building blocks of life itself?
It's super easy to look at those little dust motes dancing in a sunbeam and just feel this sense of absolute sure dread. It feels mundane and it feels endless. But today, in this explainer, we are going to completely flip that script. We're going to look at dust not as dirt, but as the most awe-inspiring, highly traveled, and chemically complex substance in the universe.
To start, we have to look closely at where we actually spend our time. The average person spends about 90% of their life indoors. That means the air we breathe, the environment we interact with the most, is totally defined by what's trapped inside our walls. So let's look at what is actually lurking in our living rooms.
Which brings us to part 1, the dust in your home. Okay, let's dive into this.
A massive global citizen science project called DustSafe recently looked at household dust from 35 countries, and the results are pretty eye-opening. Think of that little dust bunny under your couch as a microscopic crime scene evidence bag. It's literally a time capsule of human industry. It holds trace metals like lead and arsenic tracked in from outside soils or leftover from legacy paint. It captures endocrine-disrupting chemicals off-gassing from the flame retardants right there in your couch cushions. And increasingly, it is packed with microplastics shedding off synthetic carpets and clothing.
So the crucial point here is that this indoor ecosystem impacts us all, but definitely not equally. Researchers estimate that adults inhale roughly 70,000 microplastics every single day just from indoor air. But toddlers and children under 2, they face a massive vulnerability gap. Because of their lower body weight, their rapidly developing nervous systems, and their tendency to put literally everything in their mouths, they accumulate these dust-borne chemicals at a highly disproportionate rate.
Part 2. Earth's massive dust engine. We're zooming way out from your living room to the planetary scale, where dust acts as a literal engine for the Earth.
Every single year, roughly 2 billion tons of mineral dust are scooped up into our atmosphere, and it's not evenly distributed at all. A massive 55% of this global dust emission comes from just one region, the Sahara and North Africa. The Sahara Desert is the single largest dust factory on Earth, and what it produces doesn't just stay in Africa.
It powers one of the most extraordinary transport corridors on the planet. Millions of tons of Saharan dust are swept high into the atmosphere, blown all the way across the entire Atlantic Ocean, and deposited directly into the Amazon basin. And it brings gifts. Specifically, 27.7 million tons of that dust carry around 22,000 tons of essential phosphorus. This acts as a perfect natural fertilizer, replacing exactly the nutrients that the rainforest loses to heavy rains and river flooding. And it doesn't just fertilize the land. When massive desert dust storms blow over ocean regions that are starved for iron, they act as a giant fertilizer for marine life too. In the North Atlantic, Saharan dust actually doubles deep carbon sequestration by boosting nitrogen fixation in phytoplankton. These tiny organisms bloom, absorb carbon dioxide from the air, and eventually sink to the deep ocean, locking all that carbon away.
Now, what's really interesting about this slide is how dust acts as a massive, super complicated wildcard for global temperatures. It creates a complete climate paradox. On one hand, dust can scatter shortwave sunlight back into space, which actually cools the planet. But on the other hand, it can absorb long-wave radiation bouncing off the Earth, which warms the planet. Depending on the iron oxide content of the dust, the size of the particles, and how high they fly, climate models are still trying to figure out exactly how these billions of tons of dust tip the scales of our energy budget.
But we do know for sure that dust makes weather. Mineral dust particles suspended in the air act as absolutely critical cloud condensation nuclei. They provide the tiny little physical surfaces that water vapor needs to condense into cloud droplets. Even wilder, dust particles can form ice crystals across a massive range of atmospheric temperatures, sometimes triggering the full glaciation of a cloud. And this directly alters how clouds reflect light and whether or not they dump precipitation back down to Earth.
Part 3. The space dust mystery. See, Earth's dust is only part of the story. Let's zoom out even further, past our atmosphere and into the cosmos. Because tens of thousands of tons of cosmic dust are raining down on Earth every single year.
A huge fraction of this space dust is literal stardust,
created in the outflows of dying stars. And a lot of it comes in the form of carbon nanodots. These are ultra-small carbon nanoparticles. We are talking about dust grains so unimaginably tiny that their physical boundaries are actually smaller than the natural radius of an electron's orbit. That means these dust particles are entirely governed by the weird, totally rule-breaking laws of quantum mechanics.
Because they are so incredibly tiny, a phenomenon called quantum confinement takes over. This basically restricts the internal energy of the dust particle. In plain English, it means these tiny carbon dots use quantum rules to absorb and emit light in totally unexpected, brilliant ways. They basically act like little tunable fluorescent bulbs floating out in space.
This actually solves a huge mystery. For over a century, astronomers have been puzzled by something called diffuse interstellar bands, or DIBs. When we look out into diffuse galactic environments, we see these mysterious bands of absorbed and emitted light that we just couldn't identify. But now scientists realize that the weird quantum leaps happening inside these tiny space dust particles perfectly explain these mysterious light signatures. Cosmic dust is literally bending and shaping the light of the galaxy.
Part 4. The Seeds of Life. Get ready, because here is the ultimate plot twist of this explainer. The amazing connection between the annoying dust in your home and the origins of life itself.
To figure out what dust actually does in deep space, scientists recently ran an incredible laboratory experiment. They built a microscopic dust sandwich to mimic the freezing, harsh conditions of star-forming regions. They took frozen carbon dioxide and ammonia, layered them with porous silicate dust grains, and then slowly warmed the whole thing up from absolute freezing temperatures.
What they found is that cosmic dust acts as a tiny, floating thermodynamic chemical factory. Out in the cold void of space, a stray photon hits a dust grain and causes a random, sudden burst of thermal energy. That brief burst of heat causes the surrounding ice to rearrange into crystals. The shifting allows frozen reactive chemicals to migrate, bump into each other, and synthesize into brand new, complex organic molecules.
The result of this laboratory dust sandwich was the creation of ammonium carbamide. This is a highly complex prebiotic precursor to urea, which is a fundamental building block of biology. And here is the real kicker. Without the dust grains acting as a catalyst and a localized energy factory, this chemical reaction simply does not happen.
And this brilliantly illustrates why dust is just so profound. As noted by researchers, this exact same process likely happened right here on our planet. Cosmic dust particles falling to early Earth may have been the very things facilitating the complex chemical reactions needed to kickstart the geochemical origins of life. We are quite literally sitting here today because of dust.
Part 5. Back to your bookshelf. So, let's zoom all the way back down into your living room.
The next time you see that gray fuzz settling on your furniture, I hope you look at it just a little differently. You aren't just looking at dirt. You are looking at a substance that mirrors the grandest mechanics of the universe. From trapping household microplastics, to fertilizing the Amazon rainforest, to acting as a massive global climate engine, to bending quantum interstellar light, to serving as the microscopic chemical factory that birthed the seeds of life itself. Dust is the most underappreciated, vital, and awe-inspiring substance in the universe.
Wild, but true.